through these two problems from yesterday's notes. We hit it yesterday, but we did it really fast. So the first one is an AP multiple choice question that is a U substitution. So I'm going to let U be 2t. du would then be 2 dt. So 1/2 du would be dt. So I have 1/2 the integral f of u du. But the 4 and the 8 are x values, so we need to change those to u values. So the 4 would be an 8, the 8 would be a 16, which means the answer is B. Any questions about that? So if you wonder how they could test, because I told you yesterday you can use either option. You can substitute the u's in immediately, or you can go back and substitute x back in. How will AP test whether you can actually do a real use substitution? And that's how. So just make sure you know that. The second one we talked about a little bit. I think did we talk about it a little bit? We could totally do a u substitution. We could do f of b minus the antiderivative at b minus the antiderivative at a. We would get a number answer. It would work, and we would be absolutely wrong. If you were to graph this function, at 1, it has a vertical asymptote. Looks like that. So if you think about area under that, that's a dangerous question, isn't it? It's definitely not a small area that would relate to the antiderivative at 0 and the antiderivative at 3. So why does it fail us? So if you read the definition or the fundamental theorem of calculus, the very first statement it says is, if f is continuous on the closed interval AB. So if f is continuous from 0 to 3, is this continuous from 0 to 3? No. So therefore, I can't do this integral. And so the answer is divergent, which means the area is infinite. In Cal 2, you will go more into depth on figuring out that that is, in fact, infinite.
Hey,
yes?
at the end of the period, Addison Graham checked out.
Okay. Anyway, so in Cal 1, if they ask you to integrate over a discontinuity, the answer is going to be divergent because your main job is to know that you can't do that. Cal 2 will explore some functions that you can actually find the infinite area, but it's special cases and it involves limits and whatnot. Speaking of limits, let's do some. So, as you know, anything is always fair game in calculus. I can ask you anything from any chapter on any test. Well, limits have gotten pretty far away from your brain, so everything else is still pretty fresh, I think, because you think about chapter 2, it was derivatives. You do derivatives all the time. So even though it was a long time ago, you use it so often, it doesn't go away. Limits you don't use as often, so occasionally we're going to pull them back in and remind you how to do limits. So how do you do a limit as x approaches infinity? What do you think?
Exponents.
Exponents of powers, and this one has a bigger power on bottom, so as x gets really big, the bottom gets really big, you divide by really big numbers, you get really little ones. Approaching negative infinity, you have the same thought process. You look at the highest powers, and the highest powers are these two. That does reduce to 2/3 x. Does everyone agree with that? And as x approaches negative infinity, what does 2/3 x approach? Negative infinity. You do need to know which side of infinity, which way that's going, whether it's positive infinity or negative. Let's do number 2. Any ideas? Why? Okay, the absolute values is a special case. It's a special case we took the time to memorize because it was tricky. Normally, this limit would be 1. If you ignored the absolute values, this limit would be 1 because the x minus 17s would cancel, right? However, because of the absolute values, from one side of 17, you're going to get positive 1, and the other side of 17, you're going to get negative 1 because the bottom's always going to stay positive. Does everyone know what I mean by that? How you can figure that out is you could plug in 17.001, and then you can plug in 16.99999, right? And when you plug in 16.999, that's where you get the negative 1. So from the left, you get negative 1. From the right, you get positive 1, which means if we're getting two different things from the left and the right, the double-sided limit doesn't exist. Sometimes they will ask you from the left or the right. Pick a number really close, like 16.999. That would be a left hand, and see if you get positive or negative 1.
This is on the AP test, would it be on the calculator?
No. And it's because you could do that, you could even plug in 16.99999 without a calculator because the top and bottom are the same except for a sign. So it's one they feel like you can do by hand. I say no. If it shows up on the calculator, go, thank you, AP, and plug it in your calculator, and but most likely no. What about this one?
0.
Why 0? E to the 4x. Now, we're not powers, but we can still think like powers. E to the 4x grows really fast. It is the fastest growing function you know. It wins every race. It's exponential growth. Sine does not grow at all. It stays between -1 and 1. And so you take a number between -1 and 1, and you divide it by a huge number, get close to 0. Two-thirds? Now, again, when am I ignoring the rest of the function? When is that okay? When I'm approaching infinity. Does everyone remember why I can ignore the rest?
7 and 12.
Right. When x gets huge, it's the Bill Gates principle. As x gets huge, the dollars just don't matter that much, right? All right. What about this one? 4/5. Now, some of you may just have that memorized because I keep putting it on mastery, which is perfect. I like that you have that memorized. What's another option if you had forgotten that? But I could do the multiplication and look for a special limit. That's how you had to do it in chapter 1. What's the third option after we learned a special trick? L'Hopital's. If I plug in 0, I get 0 over 0, and that means L'Hopital's is an option. How do you do L'Hopital's? Derivative of the top and the bottom. The derivative of sine is cosine of 4x times 4. Everyone agree? The derivative of the bottom is 5. Cosine is 0 is 1 4/5. So you could use L'Hopital's if you get stuck. All right, number 7. Do what? The back. It's on the back. What do I do first with any limit? Plug it in. What do you get when you plug in -1? Nope. Zero. Is it 0? That's 1 plus, yeah, 0 over -6. What is 0 divided by -6? So that limit's 0. Plug it in. If it works, you're done. Stop. How many of you did too much work on that one? If it's not 0 over 0, you're done. 0 over 0 is when we have more work to do. Plug in 0. I do get 0 over 0 on this one, which means I have more work to do. This one can be done one of 2 ways, with a special limit memorization or with L'Hopital's. Do I care? Which way do y'all want to do it? L'Hopital's, the derivative is -3 sine of x over 5. And sine of 0 is 0. So that's 0. The other way, you could factor out a 3 here, cosine of x minus 1. And remember, cosine of x minus 1 over x, that limit as x approaches 0 is 0. 0 times anything is 0. And two options there. Plug in 5. I get 0 over 0. Is that right? So what do? Factor or L'Hopital's? You got two options. I would argue those take about the same amount of time depending on your factoring abilities and how hard it is to factor. This one's an easy one to factor. If it gets tougher to factor, you may want to pick up L'Hopital's. You've got options. 5 plus 1 is 6. L'Hopital's, you would have gotten 2x minus 4 over 1. 2 times 5 is 10. 10 minus 4 is 6. You land in the same spot. Plug in 1. 1 minus 4 is -3. Minus 5 is -8. -8 over 0, right? What's that mean? Good. That limit does not exist because it's a vertical asymptote. At 1, I have a vertical asymptote, so that limit does not exist. And the last one. Two options. It is a derivative in disguise. Does everyone agree with that? So it's the derivative of sine of x at pi over 4, which is cosine of pi over 4. And cosine of pi over 4 is radical 2 over 2. Option number 2, although derivative in disguise is probably the most efficient way. What is option number 2? L'Hopital's, right? I get 0 over 0. Does everyone agree? Sine of pi over 4 minus sine of pi over 4, I'm pretty sure that's 0. And pi over 4 minus pi over 4 is 0. And so if I have 0 over 0, I can use L'Hopital's. Remember, L'Hopital's does not work if it's not 0 over 0. And I can do the derivative. The derivative of sine of x is cosine of x. What's the derivative of sine of pi over 4? It's almost a trick question. Why is it 0? Because sine of pi over 4 is a constant, so the derivative of a constant is 0. And over 1 minus 0, then you plug in pi over 4, you land in the exact same place. Questions about that one?
What did you get for the bottom?
The derivative for L'Hopital's. Yeah. Now for this option, I didn't do anything. I just noticed the whole thing is definition of derivative, and f of x would be sine of x, and the value would be pi over 4. You remember that worksheet with the smiley face on it? So you have two options. Okay, so that was a limit review just for fun. Remember, they could show up on a test, so we are kind of, we still have a few things to learn, but we're kind of closing in on Unit 5's test. We will have an AP packet and whatnot, but so just a good little review on a day that you needed to work on homework anyway. So you have 15 minutes left in class. Ask me questions on your substitution homework.